All right. Hi, everyone. Welcome. Thank you for joining us here for this live stream as part of the microprofile booth by the Eclipse Foundation for J4K 2020. We're excited to be here today to talk to you all about different topics. So we'll introduce ourselves first. I'm YK. With me are Andy, Ryan, and Catherine. We are all from the Open Liberty team. Open Liberty is an open source cloud native Java runtime / framework that enables us to do microprofile and more. So we are excited here today to talk to you all about some microprofile technologies. So yeah, as I mentioned, we are from Open Liberty. We work on Open Liberty. So if you want to check out Open Liberty, just visit us at openliberty.io, and you can find out more about it there. At any time as we look at what we have here, feel free to chime in on the chat and let us know if you have any questions to interact, and we'll be happy to talk through what you have there. So here's what we plan to do today. First off, we'll take a look at microprofile GraphQL, and we'll be doing that in just a moment. And after that, at 3:35 p.m., Ryan will be showing us about language server, the new language server for microprofile. That's also another open source project under Eclipse Foundation that's related to microprofile, right? And lastly, at 4:10, Catherine will come in and show us about some of the developer toolings or tools available for developer to build microprofile applications. So that's our plan for today. And yeah, so at any time, just chime in on the chat and let us know if you have any questions. So without further ado, I would just hand the time over to Andy to take us through GraphQL.
All right. Thank you, YK. I'm going to try to keep it kind of casual since this is supposed to be a virtual booth. Try to make it seem a little boothy-like. In fact, when I told my wife I was presenting today, she decided to make it more like a real conference by ordering a play date for my kids and having a contractor come over. So it's even though it may seem a little quiet right now, it seems like Grand Central Station to me. So anyhow, I'm Andy McCrite. I'm the web service architect for Open Liberty, and I do a lot of work with REST and REST services, and more recently with GraphQL. And so today I kind of wanted to talk about some of the stuff we've been doing with microprofile GraphQL, both in the microprofile community and within Open Liberty. The talk that I have today is probably really more like a 45 to 50-minute talk, so I'm going to go through it kind of quick. Please, if you have questions, though, be sure to use the chat feature here in the app to ask. I'm not going to go too much into what microprofile is. I will say this, though, if you're not familiar with microprofile, I highly encourage you to start Googling it and read up on microprofile. If you're doing any kind of Java work in the cloud, these APIs are essential, whether it's MP-config or the REST client or fault tolerance APIs. If you're going into the cloud, these are APIs you really need to be aware of. I do want to talk a little bit about GraphQL outside of Java and outside of microprofile. Basically, it was a sort of a data query language designed by Facebook and initially implemented in JavaScript, and it was made open source back in 2015 as a specification and then a reference implementation. Basically, GraphQL, it doesn't have to necessarily be an alternative to REST. It can complement REST, but it's really designed to address some of the gaps that you see in RESTful services. And I'll talk about that more as we go along through the presentation here. Some of the things about GraphQL is that, like REST, you can do queries and mutations. So you can do reads, which is similar to a REST GET, or you can do creates, updates, and deletes, which are mutations. You perform those operations on entity types, very similar to REST. What's different about GraphQL is that you can specify which fields you want returned, giving you a little bit more of the feel of just getting exactly what you want. GraphQL uses schemas, and those schema files basically allow the client and the server to come together on basically like a contract. It specifies the output types, the input types, and allows both sides to kind of negotiate and have a strict understanding of what the service offers. GraphQL primitives are known as scalars. The default in the GraphQL specification just has 5 scalars: string, int, float, boolean, and ID. But implementations are allowed to define their own scalars. Some of the more common scalars out there in GraphQL today include things like URIs, URLs, dates, and time, and things like that. So sort of like effectively the primitives for most programming languages. So why would you use GraphQL either in addition to or instead of REST? One of the main things is that it avoids overfetching and underfetching. So with a single round trip to the server, you can get everything you want. And that's something that REST, I think, struggles with. I mean, most of the things that I'm going to show you today are possible with REST, but it requires a lot more code, a lot more complexity. GraphQL makes it very easy to get just what you want. The next nice thing about it is that it allows your data models to evolve. So as long as you're not deleting fields from your entities, you can add fields and make changes without requiring a version 2 of your app, which is very nice, because when a client is only accessing fields A, B, and C, if you add a D, E, and F that might throw some incompatibilities to them, the client isn't looking for D, E, and F, so they can continue accessing fields A, B, and C just fine and continue on even though you've updated your application. Number 3 here is partial results. When you run into an error situation, you can return some results, allowing the client to have some information, maybe make some progress, even though the full request failed. If we have time, I'll demonstrate that. And then, as I mentioned before, the schema allows both sides, the server and the client, basically to work under contract, and they can. There's not a lot of communication outside of the schema that's necessary, which makes things very, very practical for client-side development. There's a lot of tooling out there today allowing native schema introspection. I'm going to show you a tool called Graphql that we use. Basically, those kind of tools allow you to introspect the schema and provide very easy interfaces for designing queries and designing mutations, complete with command completion and everything. So, and I'll show you some of that a little bit later. So, what does Microprofile offer to GraphQL? Well, so it's a Java implementation of GraphQL, but beyond that, it's a specification, so it allows other entities, other implementations to support this. But like Jakarta EE or Java EE, if you're familiar with that, it's sort of a write once, run anywhere kind of model. So you could start with running your application in OpenLiberty or in Wildfly and use the smaller I implementation. But I've been working with some of the folks from Oracle, and they're coming up with their own implementation. So if you wanted to move your application from OpenLiberty to Oracle, you could do that and then use their application. And there's complete with a TCK, so that you know what APIs are portable. So that's one of the nice things about Microprofile technologies. The goal for this is a code-first approach. So I mentioned a schema, and a lot of the implementations out there of GraphQL tend to kind of require that you design your schema first and then implement your server based on that schema. And the issues with that is that a lot of times you're doing kind of dual maintenance, because eventually you may find something that you need to implement in the server. You'll have to go back to the schema and add that code into the schema and then go implement that in the server. What we want to do when Microprofile GraphQL is basically keep the API design in the code. And so that's why we borrow ideas from things like JAX-RS, where you can use annotations to annotate and say, okay, this is a query. Make sure that this query gets added to the schema. And then the schema is generated on the fly at runtime. If you want to know kind of the origins of where this came from, we were based very strongly on the GraphQL speaker project at the link listed here. So now I want to get a little bit more practical, and we'll just kind of, for the sake of argument, we're going to look at a weather app. So you've probably all used tools like weather.com, Weather Underground, AccuWeather. All these services are great, and most of them offer a RESTful interface. I've noticed that, and I've noticed that most of them also do not offer a GraphQL interface. And I kind of want to make that change, because I think there's a lot that GraphQL could do for guys like AccuWeather or weather.com. So in our app, what I'm going to show a little bit later is something that's kind of like one of these weather sites. But unlike those real guys, we're going to just totally generate random weather data. And so at this point, it's just going to be a database of a hash map that'll have current conditions. But in the future, if we wanted to mess with it more, we could actually make it more IoT based and do more like having a weather station that actually pushes in weather data. But for now, we're just going to keep it simple. So the boss comes by and says, hey, we want to have a portal app that adds a web page widget, or maybe a Slack bot or something like that, that will tell us what the current conditions are in our area. And so to implement this, so that's our client, right? Our client is this widget, and our server is this weather service. And so what the client might do is it might issue a RESTful request here to something like AccuWeather and say, get the current conditions for this zip code. 30313 is the one of the zip codes in Atlanta where I first presented this. And so it would issue an HTTP request like you see here, and it would end up getting a lot of data. And I'm not gonna, like I said, I gotta kind of speed through some of this. There's a lot of data here, right? So we've got temperature, we've got I think there's so Fahrenheit and Celsius, but there's a lot more, right? So there's humidity, wind speed, wind gusts, UV, pressure tendency, apparent temperature, wet bulb temperature. We'll talk about that a little bit later. And then we've got stuff like, well, what was the precipitation summary from the last 3 hours? What was it for the last 12 hours or 6 hours? And then, past 24 hours. And we get all this data, and I ended up counting this. This is basically 10 pages full of JSON data for weather, when probably what most people are interested in is just, what's the temperature and is it raining? So that's what we call overfetching, right? One request gets us 10 pages worth of data when really we only need, 2-4 fields at most. So now let's say that the boss says, hey, this is, the scope, this never happens in real life, right? The scope never creeps. So, but no, the boss says, hey, we got 3 other sites that are interested in this. So we need to issue that same request 3 times, right? So that's what we would call underfetching, because with REST, we would have to make 3 separate requests. One for our site in Rochester, Minnesota, that's where I'm from, one for Atlanta, and one for Beverly Hills. And all 3 of those are going to have to parse through that 10 pages worth of data, but now we're doing it times 3 for each one. So that's what we call underfetching, right? Now we have to go out and make 3 round trips to get the data we need. So this is where GraphQL is designed to help us, right? It basically allows us to make a single request, a single round trip, get just the data we want for all 3 sites, because we can submit multiple queries on the same request. So what we have here is an example of a schema. So this will be, I'll show you the code that generated the schema. It's actually a little bit more verbose than what you would see if you were to look at it now. This is a few months old, but it has a type called conditions. Those are the current weather conditions that we have. And so it's got a few fields on there. It doesn't have quite as many as AccuWeather or weather.com, but it does have fields like the location, the precipitation type, the temperature in Celsius, temperature in Fahrenheit, weather text, which would basically say something like sunny or cloudy or whatever, and wet bulb temperature, my favorite. Then we've got down here at the bottom, we've got an enumeration of precipitation type. And we'll just have rain, sleet, and snow. I'm sure there's probably others. I'm not a meteorology major. So then we have the query. We have two queries here, and we'll talk about the two different ones. One is current conditions, in which you pass in a string, and then you get a conditions object back. The other is where you could pass in a collection of strings or a list of strings, and you'll get multiple collections back. So you'll get basically a list of conditions back. And that's partially to show you some of the partial results that you can get on an exception. So this is what your query would look like. You would say, give me 3 locations, the location, give me the current conditions for Atlanta, for Rochester, Minnesota, and Beverly Hills, California. And we pass in the 4 things that we're looking for. Is it precipitating? What's the temperature? What's the weather text? And what's the precipitation type? And then the response you get back looks like this. It's in JSON. And that's something I'll point out over here. The query is its own query language. This is a GraphQL query language. The data you get back is in JSON. And so you get a JSON object back with your data. The points here match your query. So for Atlanta, you get 4 fields. You can see it's not precipitating in Atlanta, but it is in Rochester. We're getting snow and it's overcast, but it's sunny and pretty cold in Atlanta in this fictional report. So at that point, I think it's time to take a look at the code so you can see just how easy it is to build a service to provide weather like this. So I'm gonna come over here, and I'll probably need to increase the size of my text here. So I'm actually running the service right now in Open Liberty using the Maven plugin, which is really quite handy. So we have a POJO called conditions, and that maps directly to what we saw in the schema. So we have fields like location, the local observation time, weather text, has precipitation, precipitation type, and that's an enumerated type that we can look at over here. And one thing I want to mention here is that at this point, nothing is really annotated, right? There's nothing that all this code is basically your model, right? Your business model and application. So nothing here is really specific to GraphQL or to Microprofile GraphQL. And so then for all of these things, for all of these fields, we have getters and setters, right? Get weather text, set weather text, etc. We've also got an exception type, which again, this is more of like a business exception. It's called unknown location exception. And obviously that's going to happen. That's going to happen when a client says, give me the weather conditions for a location that we've never heard of. So really the interesting part of this application is the weather service class. And this class imports a lot from org Eclipse Microprofile. These are all the mutations that we use in NV GraphQL. We have a CDI object that's application scoped in this case, and we have this decorator that says it's a GraphQL API. That tells the implementation, look here for root level queries and mutations. And so here's our database, our hash map of conditions. And we have a very simple current conditions method. We've labeled it as a query. And so we use this @name so that we know what the parameter types are. It is possible to avoid the annotation, but only if you compile your code with and preserve the parameters. So we recommend that you use @name so that we can get the name of the parameters. You could also add things like @description. If you wanted to say something like get the current conditions of the specified location. So, and then that description would then go into the GraphQL schema. So in this case, we've got basically it's just going to get take the location from the parameter that's passed in from the client. It's going to generate some random weather conditions and stuff that into a hash map. If it's already in the hash map, it'll just return it. So pretty simple. And you know, I don't mean to brag, but my code is so robust that it works for any location on Earth, even in the known universe, except for one place. Nowhere is going to throw an exception. So, so you can see pretty easily, it's a very very simple way to create your first query, right? This is your hello world query. We've got another query here for taking a list of locations. You can ignore this for now, but in the Open Liberty implementation, we also allow you to have some security, but I've disabled that for this. And same thing with the roles allowed. So if you wanted to create a mutation, you would just use the @mutation. And then you could pass in parameters here like we did with the query. In this case, it's just basically resetting the conditions map. So it's basically clearing our database. So if we want to see what that looks like, here is the Graphql user interface. You can click on the docs and you can start exploring the queries and mutations that you can do. So you can see like, well, what does conditions give us? And this is all from the schema generated by Microprofile GraphQL. So let's take a look. We have I did just reset it. So we have 3 sites: Rochester, San Francisco, which has a slightly different zip code, and Beverly Hills. And so when we run that, we get random weather conditions. It's not currently snowing here, but I can tell you that in Rochester it is pretty cold today, so it's not too far from the truth. So that's GraphQL in a nutshell. Now, one of the things we talked about was error handling and sending partial results. So I want to take a look at that too. You saw before that if you pass in nowhere, if you pass in a string called nowhere for one of the locations, it's going to throw an unknown location exception. So let's take a look at this query here. Let's look at this query here. And in the second spot, we're actually looking for the location of nowhere. So when we run this, now our returned data has an error. It tells us there's an unknown location exception caused by some data fetching issues. And so we know that there's an error. So when we look at the data, we still see that we still get Rochester's data. It still shows the same data because it's in our hash map. So it's still snowing in Rochester. We have null for nowhere, but we also have our data for San Francisco and Beverly Hills. So the client can still make it take advantage of that and still use the data that it has for 3 out of 4 locations. See, I still got a few more minutes, so let's delve in a little bit more and look at that current conditions list. Because one other thing you can do is if you don't have, in this case, we sent 4 queries in one request, and one of the queries happened to break, right? So that's the other 3 queries were our partial results. But you may get into a situation where you have just a single query, but you still want to be able to send back partial results, even if in the case of an error. So that's what this is. It's kind of a contrived example, but the idea is you have a list of locations that you're going to look up, and you're going to send back a list of conditions that match. So, if they send Atlanta, Rochester, and San Francisco, they'll get back a list of conditions, current conditions for those three sites in that same order. And so it does the normal thing where it iterates over the locations, and it actually calls our other method up here that randomly generates it. And then if nowhere is one of them, it's going to throw that exception, right? So it catches that exception, but instead of rethrowing unknown location exception, it throws a GraphQL exception. But then it passes in all the locations that it's obtained so far. So it's going to throw the exception. It's going to even throw, pass in the caused by, so that you can get some data back on the client side. And so we'll see. Let's take a look at what that looks like from a client. So if we have three sites in a list, the query is going to look something like this. So here's our 3 zip codes, and this is the data we're looking for. We get back data, and it's going to look a little bit different. Remember, when we did it before, we labeled our queries, and so we got 3 different queries, and so we had the list, the name here. So what you might want to do when you're doing a query like this is you might want to include the location with it, so that you can easily tell which one is which. So now we know this one is the one from Rochester, this one's from San Francisco and Beverly Hills. But now, if we have a query that includes nowhere, so now we've got 55901, we've got San Francisco, nowhere, and Beverly Hills. Do the same thing. We'll go ahead and add the location in there too. Type. Now we still get the error because we still passed in nowhere. And it even tells us which line the issue is in. So it gives us some diagnosis on what's wrong with our query. But in this case, it only shows the data for the 2 sites that were before it, because that's the way we designed our app, right? We could have it to where it catches an exception, keeps iterating over it, and then just gets back as much data as possible. But that's just the way we designed our application, which is, this probably is kind of a contrived example, but you can see the power of being able to pass back partial results in the exception, because the amount of code we've written here is actually pretty minimal when it comes to developing our GraphQL application. So I've got a couple more minutes. I want to talk real quick about one thing, and that's this wet bulb temperature. There might be times when on the server, you don't want to look up something unless you know the client is interested in it. And so that's this case for wet bulb temperature. So under here, I've got a to-do, because we don't, wet bulb temperature is something that we'll just pretend like it takes a little bit more processing time to get that particular meteorological condition, right? So you don't want to spend time calculating wet bulb temperature if the client isn't interested in it. So we've got this system out that prints only when this has been executed, and you can see that so far in my logs down here, we haven't run this because none of our client requests and all this examples has actually requested the wet bulb temperature. So what you can do, the way you do that is you have a method, and usually this method has to be on a class annotated with GraphQL API. It sources in the type of the return type, the output type. So we're returning conditions, both in current conditions list and in current conditions. So when we return that conditions, it'll pass that conditions to this method, but only when the client has requested wet bulb temp. So let's do that now. Let's go back over here, and let's go back to one of our easier queries, and we'll look at this, and we'll just look for it specifically in Rochester. Then when I run that, we see the wet bulb temperature is basically just 3 degrees lower than temperature F, because I don't have a lot of weather imagination. But when we come back, now we see that it was looked up, but it was only looked up for the Rochester zip code, for 55901, not for any of the other ones. And that's because of the source annotation, which allows you to not only provide the client only with what it's looking for, but it also allows you to save cycles on the server if you don't need to look up something. So imagine that you may have a database on a mainframe that's going to cost you real money to look up something. You may not want to do that unless the customer's actually the end user really needs that information. This would be a way to kind of gate that so that you aren't getting that information for every client request and only getting it for the time that you really need it. So I think I'm running out of time. So I think I've covered just about everything. Let me just make sure. Yeah, I covered that. So basically, I just want to mention this is so far we've talked about only on the server side, and this is all in the Microprofile GraphQL 1.0 release. We're not done yet. We've got lots more work to do. And so the question that we get is, well, what's next? What's coming up? So we've been making refinements, clarifications, and minor fixes in the spec and the APIs. We love getting feedback from people because they're using our product, and if there's something we can do to make it better, we want to hear about it. So please let us know if you give it a try. We know one of the things that we've always had on our plan, but haven't gotten to yet, is our client APIs. We've been looking around. We've actually made a lot of progress in the realm of client APIs, and that should be in our next release, which is we're tentatively calling GraphQL 1.1. So that'll add some client APIs so that you can, from a Java application, issue those queries without having to get to the low-level Apache HTTP client kind of level. We try to make it as easy as possible to invoke those APIs, those GraphQL APIs. Subscriptions is another part of the GraphQL spec that allows you to get notified when certain entities have been modified or have been queried. And then the other thing is to basically make it so that your application can design custom scalars and make it super easy for your data types to be converted from object to GraphQL. And so that's pretty much it. So in summary, GraphQL fills in some gaps in REST. It particularly attacks overfetching and underfetching, provides partial results, etc. Microprofile GraphQL makes it easy to develop and deploy GraphQL applications. And everything we've done, everything I've talked about today is all open source. If you want to look at the sample, it's out on GitHub. We use Open Liberty. For the demo, you can also run it on Wildfly or Quarkus. And then the project itself, the Microprofile GraphQL project, is all open source. So if you have any feedback, any questions, please let us know. And if you need any of the links or coordinates, that's this right here. I think I will now stop sharing and turn it back over to YK. I don't know if we have time for any questions or not.
Thanks, Andy. It's been great, and it's a great introduction to GraphQL and also a demo of how it works, right? As you can see, as Andy showed, it's really easy with the what Microprofile has attempted to do for GraphQL. Makes it easier for us to build what we want to do to use our GraphQL to make things more efficient for REST, working with REST services, right? So, yeah. Thanks a lot, Andy. And as Andy said, if you have any questions, don't hesitate to reach out directly to Andy or join in on the Microprofile mailing list or just look up more information out there, right? So, all right. So thank you, Andy.
Yeah, thank you.
So this is the first topic that we have here, and that's around GraphQL. And if we will look at what we have next, it's going to be around language server for Microprofile. So Andy did the GraphQL talk for us on demo, right? So if you have more questions, reach out to Andy at Andrew McCright there. So now looking at the time, it's 3:35. So we'll just move on to the next topic and demo. And Ryan will be showing us the new language server for Microprofile. So Ryan, do you want to take it away? Whenever you're ready. Thank you.
Sure, just let me share my screen. Okay, so I'm going to be talking about the new language server for Microprofile and the VS Code client that comes along with it. So I guess first, what is Microprofile? I'm sure most of you probably heard a lot about this recently, but if you are still a little confused or don't know, Microprofile is an open source community specification for enterprise Java microservices. And it's a community of individuals, organizations, and vendors collaborating within an open source, an Eclipse project to bring microservices to the enterprise Java community. So Microprofile is made up of a bunch of specs like config, health, REST client, JAX-RS that are all kind of designed for developing cloud native microservices. So what is a language server? So a language server provides language-specific features such as code complete, hover, go-to definition, quick fixes, and diagnostics. So a language server communicates with a code editor via the language server protocol. And the language server protocol was something originally developed at Microsoft, and it is an open source protocol specification to standardize the communication between code editors and language servers. So you might be wondering, why do we need the language server protocol? What is the benefit of that? And so before language server protocol, each editor would have its own API for adding language features. So with LSP, there's one standard API, so one server implementation can work with multiple editors. So instead of having to re-implement the same language features for each editor you want, you can reuse the same language server, and because that language server runs in its own process, it can be written in any programming language. So now that you understand what Microprofile is and what a language server is, what is Eclipse LSP for MP? So LSP for MP is a language server implementation based on the language server protocol for the Microprofile programming model. So it provides core language support capabilities like code complete, diagnostic, quick fixes to enable developers to easily and quickly develop cloud native applications using Microprofile APIs. So LSP for MP is a Eclipse project under Eclipse incubation, and it has contributors from Red Hat and IBM and external in the Microprofile community. So before I do a demo, I'll quickly go over the architecture just so you can kind of have an understanding of what's going on. So LSP for MP is made up of two components. So there's the Microprofile language server itself that provides the language features using LSP to your editor, in this case, VS Code. And then there's also the Microprofile JDTLS extension, which is an extension to the Eclipse JDTLS, which is the Java language server. And what that does is it provides Java project information to the Microprofile language server. So this includes information like class path changes or AST or abstract syntax tree information. And then these two components communicate to each other through the IDE using JSON RPC. So they can't communicate to each other directly. And so you may be wondering, why is there two components? Why not just have one language server that powers everything? Well, the thing is, Java already has excellent language support. So this is the Eclipse JDT and the JDTLS language server. So when we implement our own Java support, we don't want to duplicate the work that's already being done by the JDT. So again, computing the class path, building the abstract syntax tree. So the solution for this is to reuse what we can from the JDT through the Microprofile JDTLS extension. So the Microprofile language server will communicate with the JDT and ask for information that it does not know on its own, so that it doesn't have to compute it itself and duplicate the work. So an IDE client is what kind of provides the language server capabilities from the language server to the IDE itself. So this normally comes either built into the IDE itself or through a lightweight IDE extension. So for LSP for MP, we have the tools for Microprofile VS Code extension that provides support for the development of microprofile applications. And we are planning to soon bring support for Eclipse and the Intellij IDEs. LSP for MP can also be extended by individual microprofile implementations. So LSP for MP provides language features in both properties files, so your mpconfig.properties file, or Java files where you're using microprofile APIs. So third parties can extend LSP for MP to provide additional functionality through Java SPI. So for example, Quarkus extends LSP for MP to provide additional Java snippets, as well as Quarkus-specific config properties. So where are we right now with LSP for MP? We just came out with the first release recently, and as well the first release of the tools for microprofile VS Code extension that uses LSP for MP. And then we are working on bringing support to other editors. So what APIs are supported? We have a bunch of APIs currently, and we're always working on bringing support for more APIs and bringing it up to, I guess, current with the current implementation of microprofile. So we have completion and diagnostics for both properties and Java files, as well as code actions and code snippets for select microprofile specs. So now I will just talk about, I guess, or show a demo of how it works. So I have here just a basic microprofile application that I developed, or that I generated with Microprofile Starter. And this is an Open Liberty application, and I have the application running here in dev mode, Open Liberty dev mode. So I have here just a basic health check. And while I'm developing my health check, say I accidentally delete an annotation that is needed for the health check to work properly. LSP for MP and the microprofile language server will provide diagnostics that will say that I am not using this annotation, and will even provide quick fixes to automatically insert it for me. As well, since I already have a liveness check here, say I want to create a new readiness check. I can use the MP readiness code snippet to automatically create the check for me, and then I can use VS Code Java to automatically fix the package name. And then there I have a fully working readiness check up and running. And then so if I go over to the health endpoint, I can see my readiness check is there and available. So along with health information, we provide support for other microprofile specs, such as microprofile REST client. So here I have a simple REST client that just interacts with the HTTP bin REST interface. And so here I define just some basic endpoints that it's going to try to hit. So I have one for UUID or status, or the different statuses. And so LSP for MP will go over and look in my microprofile config.properties for the base URL that's configured here. And then it will actually go and show the full URL here that I can click. So if I click on this, I can get a new UUID. So that's the actual endpoint that it's hitting right there. And then again, so if I want to use that REST client that I generated or that I created, you need to inject it. But again, if I forget to do something, say I forget to use the REST client annotation, LSP for MP uses its knowledge of the microprofile APIs to kind of, again, provide diagnostics. So you can see here it says that REST client object should have the REST client annotation to be injected as a CDI bean. So it caught something that I missed and will even provide a quick fix to automatically insert that annotation back that was missing. And then so LSP for MP has a lot of features based around MP config. So for example, I've defined here a config property called injected.value. And if I hover over that value, it'll show me the actual value that's defined in my microprofile config .properties file. So if I look here, it's set to injected value. And then if I go back to the config file and hover over it, it'll show me what that value is currently set to. And then if I create a new one, a new config property, say I call it injected int, and define a private int injected int. If I go back to my mp config .properties file, injected int shows up here, and it provides information like type int. So if I go and put in false, I end up with diagnostics that tell me that an integer is expected. So it understands the types and what your config properties are, and then will provide diagnostics for that. In addition to config properties you define yourself with the config property annotation, LSP for MP will look and try to figure out what microprofile specs you're using on your class path or in your application. And then it will provide completion options, diagnostics for the properties from those microprofile specs. So you can see that I was using microprofile health. So if I try to use the MP health to disable the default procedures config property, if I start typing, I get completion options right away, as well as some documentation about the property. So I can see that it's a Boolean and that it comes up with a quick description here of what it does. And as well, you can cycle through all the different properties available. So I have ones for JWT and metrics here as well. But so I can go and use the completion options to complete this property right away. So that's the basics of the features provided by LSP for MP and the microprofile language server, and the VS Code microprofile extension.
Sorry, we to a bit of a connection issue here. Hopefully you folks can hear me now. So thank you to Ryan for sharing with us on Eclipse, the language server for Eclipse microprofile, about the project itself and what the capabilities that the language server provides at this point in time, especially for VS Code through tools for microprofile extension. So we'll continue with the next topic at 4:10 as planned. And if you have questions in the meantime, don't hesitate to post in the chat. And feel free to reach out to us at any time if you have more questions. So show what we have here again. So Ryan talked to us about language server earlier, and then feel free to reach out to Ryan at Ryan Ziegler. And then when we get to 4:10, Catherine will share with us around on developer tools for microprofile. All right, it's me here again, YK, getting ready for us to continue with our next topic. Thank you for joining us and staying with us here. So Andrew earlier when we started the stream talked about GraphQL and how you would do it with microprofile with OpenLiberty. And then Ryan came in and showed us about the new language server for microprofile and how it helps developers to make, to code microprofile applications with assistance. And now, Catherine, thanks to Catherine. Catherine will show us about some tools that are available to developers for building applications with microprofile. All right. Whenever you're ready, Catherine, please take it away.
All right, thanks, YK. So today I'm going to walk you through some of the tooling that exists around microprofile and how that can help developers. All right. So the first thing I I want to talk about is project generation. So today I'm going to show you some of the tools that exist in Intellij and VS Code and how that can help you as a microprofile developer. So the first thing we want to look at is how do we start, how do we create a starter project? And that's where the Microprofile Starter extension comes in. So this exists as a web app if you just want to generate your project. But today I'm going to show you how it works in VS Code and Intellij. So here in VS Code, you can see I have this microprofile extension pack. This just bundles together all the microprofile specific VS Code tools that exist, such as the Microprofile Starter, the Microprofile REST client generator. I'll give a little demo about how to use that. The tools for microprofile extension, which Ryan just previously demoed, but you'll see a bit of in today's demo as well. That hooks into the microprofile language server and provides you with some language support. And then we have our runtime specific tooling. So Open Liberty tools, Quarkus, and PyAir tools. So these are all runtimes that support microprofile. All right, so for today's demo, we're going to create 2 REST services and have them connect to each other. And perhaps maybe this will be deployed onto Kubernetes in the future. So we'd want to also include some sort of health configurations and use microprofile health, microprofile fallback to get some metrics on our application. So the first thing I'm going to do is generate a new microprofile project. And here you can see I can do that with the Microprofile Starter. So I click generate a new microprofile project. And today we can make a simple maybe cafe app that connects to a menu service. So we'll start with our menu service. And we can pick our microprofile version. And then here are all of the servers that are supported by that version. So I'm going to pick Open Liberty Java 8. And you can also pick microprofile specs that you would like to see included in your application. So for our first, this will be a very simple example, so I'll just pick Open API for now. And where to generate into. So we can see it says here, project has been generated. We'll add it to our workspace and take a look at what we have. So since I have the Open Liberty Tools extension enabled, you can see I have this Liberty Dev dashboard in my VS Code IDE. And you can see already this has been populated with the project we just generated. So this will detect any of your Open Liberty projects in your workspace and add them here just so you can use these helpful commands to start up development mode. So I'm going to go ahead and right click on the project and hit start. This is starting our Liberty Dev mode. This is the hot reload, hot deploy tool we have for Open Liberty that will recompile and redeploy your code without having to start up your server all over again. So if we take a look at the POM here, you can see it's pretty simple. We have our microprofile dependency as well as our Liberty Maven plugin, not a whole lot else included. And so if we look into the code, we just have 2 classes here. We have our menu REST application. And I'm just going to remove the data from our application path. And we also have this hello controller class, and this is just a class that returns hello world. So here in our terminal, we can see our application has been started at the default port. That's 9080 for Open Liberty. So I'm going to go to that port and try to access our hello endpoint. So we should see the hello world returned. There you go. And if we make a change to this code and save, you can see upon save, our application has actually been recompiled. That's coming from Liberty Dev mode. And if I refresh my endpoint, we should see our change reflect on our server. All right, perfect. So let's get into creating our menu application. So the first thing we want to have is just a definition of what a drink might look like. So this will be very basic for our example. We'll just have it consist of a name and a cost. And I'm going to use JSON objects here. So I'm going to use this JSONB creator annotation. And similarly, I'll use the JSONB property annotation here, just to declare our name and our cost. All right, so we have our drink here, and you can see our code is being recompiled. Now we need our service for this, our REST service. So I'm going to call it menu service. And this is where the tools for Microprofile extension can come in handy. So one of the features of the Microprofile language server is code snippets. So here, if I type in JAX-RC, you can see it's a snippet for a JAX-RS resource class. If I select it, we have a full JAX-RS resource class template here for us to work with. So that sort of removes some of the obstacles in setting up our class. So I can just make a few modifications to this. I'll change the endpoint to maybe menu. I'll have it application scoped. That just means there'll be one instance of this class per application. So we'll be using JSON, so I want it to return JSON. And consume JSON. All right, so our menu service, we want it to store our menu, so I'll just use a map to do that. You can see here in the console, if you have any compilation errors, they're returned to you here in the console telling you that the source compilation had errors. All right, so we have our menu map here. The first thing we want to do is have a method to create a drink item. So I'm going to use the post operation here and just create a new create drink class here. And I'll use the query param for this as well. Again, if you have any questions about what I'm doing, feel free to comment in the chat or ask your questions there. I can always slow down or show you more in depth. All right, so creating a drink, we'll just create a new drink object for us and add it to our menu. So that's one method. And then we want to initialize our menu as well. So I will use the post construct annotation here and just initialize our menu. So say coffee. Maybe green tea. All right. And then we'll have one final method that actually returns our menu. So I'm going to use this get method that came from the snippet. I can just remove the produces. It'll return a collection of drinks. We'll call it get menu. And we'll just return the values from the menu. All right, so that should be enough for our menu service here. So let's try accessing it. I'm going to go to 9080/menu per our path annotation here, and you can see we have our menu populated with the two items we've added here. Now, microservices typically are connected to other microservices. So we would actually want to connect this service here to maybe another service for the cafe. So we'll connect the two using Microprofile REST client, and I will show you how to do that. First, I'm going to delete this hello controller class here since we don't need any more. And if you'll remember, I selected Open API when I generated my project. So we can now access this Open API endpoint. We can take a look at what we have here. This is our Open API file for our application. So you can see it has our menu path and our two methods, create drink, get menu. And it also defines a schema for our drink object here. So we're going to use this when we generate our Microprofile REST client. So the next thing I'm going to do is create a new project. I'm going to call the Microprofile Starter to do that. And this one, we'll call it our cafe service. Again, I'm going to select Open Liberty, but if you prefer another runtime, you can always choose another runtime, and you can still connect your services even if they're using different runtimes. And now I'm going to pick a few more microprofile specs. So I might want some microprofile config, fault tolerance, some metrics, and some health checks. So we'll generate into the same folder and add it to our workspace. So you can see now we have this second folder here called Cafe. And if we take a look here in our POM, it's pretty much the same as our last application. You can see our dashboard here, our Liberty Dev dashboard has refreshed, and we can now see our Cafe service as well. So I'm going to first just change the port that we are using since we still have our menu service running. We don't want to have any port conflicts. I just changed it to 9081 and I'm going to start up that application. So again, I just started it using the Liberty Dev dashboard, and this plugs into your VS Code terminal. So we can still see our two applications running here, and we'll wait for that to start up. If we look into our Java code here, you'll notice we have quite a few new folders. So we have our Hello controller template class that just returns Hello World, as we saw before. Our application path, again. And then you'll see we have this config, health, metric, and resilient folders. And these are coming from the microprofile specs that I selected when I generated the project. So if we look at config, we have just a sample config test controller here. If we look at health, we have two health checks already written for us, just one for live and one for ready. For metrics, we have a sample metric controller. And resilient, this is microprofile fault tolerance, and it has a fallback method here. So this is great template code to start with, and you can obviously build them up to perform meaningful tasks as you see fit. All right, so it says our application has started up. We can test that by accessing our Hello endpoint for our 9081. And this one is data hello because we have data in the application path here. So it should return hello world, which we see here. But what we really want to do is connect this to our menu service. So I'm going to right click here on this folder. And you'll see there is this option to generate a microprofile REST client. And this is coming from the microprofile REST client generator VS Code extension. So I'm going to select that. And what we can do is provide an OpenAPI file to generate a REST client interface from. So I'm going to select generate from a URL. And I'm going to provide it with the OpenAPI URL we looked at for our menu service. Confirm where to generate, confirm the package name. And here we see successfully generated a microprofile REST client interface template. So you'll see I have two new folders here, a models folder and an API folder. So our models folder has a drink.java, and I can remove some of these unused imports. But what this is a drink class with our name and our cost and a few getter and setter methods for that. And so this is being created from that schema we saw in our OpenAPI document. So our model is fully created for us. And if we look at our API folder here, you'll see we have a few exception mapper classes, and we have this default API class. Now, this default API class is actually a REST client interface, so you can tell that by this register REST client annotation here. And what it's done is define our two methods that you saw previously. So we have here our post for create drink and our get for get menu. So without having to code anything, we already have a functional REST client interface. Now all we have to do is hook it up with a controller. So one more thing we have to provide microprofile REST client with is the URL to our menu service. And we can do that in our microprofile config.properties file. So the microprofile language server, or tools for microprofile VS Code extension, offers language support not only for your Java files, but also for your properties files. So you can see here, as I start to type, we have some microprofile specific properties that are being code completed for us. What we're interested in is URL. So you can see as I type URL, I actually can tell where our register REST client class is here, our default API class, and it code completes for us, so we don't have to type all that out. And all we have to do is link our URL. So I'm just going to link the 9080 here and save that. Now, if we go back to our default API class, you'll see we have this code lens that's coming from the Microprofile language server, and it's connected to that value we just set in our property. So it's showing you what endpoint we're accessing through this menu from our menu service. So it's a clickable URL, so that could be very helpful, especially if you have a lot of these methods. Yeah, so when you click it, it takes you back to the menu endpoint of our menu service. So now that that's all hooked up, let's create our cafe controller class. So again, I can make use of the snippets from the Microprofile language server just to make it a bit easier to generate our class here. And I'll just change this to cafe. Again, we want to have this as application scope. So the first thing we would need to do is add our REST client. So we can type REST client. This is the annotation coming from Microprofile REST client. If you hover, you can see the definitions. And that's our default API class, and we'll call it our menu service. You can see I've got this warning here, and this is telling me that I've injected I haven't injected my REST client object properly. So this is a diagnostic coming from our Microprofile language server, and it's telling us that if we're going to use a REST client object, we have to inject it as a CDI bean, and I can just select the quick fix to correct that. So now I have it injected, and I just need to implement our method. So again, this will be a JSON, and I'll say it's at the get menu, and this will just be a method that returns us the menu from our cafe service here. So it should be a list of drinks. And we'll call our menu service get menu and throw the proper exceptions. Right, so we see source compilation was successful here. And now we should be able to access this endpoint. So we want to go to 9081, that's our cafe service, and data cafe/get menu. And this should call our menu service and return it through our cafe service, which it does here. And we can even, if we wanted to call like create drink, we could make a new drink. And if we refresh, we should see that drink added to our menu. There you go. All right, so that about covers the creation of the application, but I want to pivot over to Intellij to show you some of the tools that exist there and talk a little bit about testing. So I'm going to go ahead and stop my application. You can do that through the dashboard, or if you want, you can do it directly through the terminal. All right, so I'm going to close VS Code, and we'll take a look at Intellij. So as with VS Code, we have a Microprofile Starter extension for Intellij, and this is just enabled under the new project wizard once you have this extension installed. You can see it has the same options as before, where you can enter the group ID, the artifact ID, the version. You can choose your implementation as well as some specs. I'm not going to generate a new project now. I'm actually going to talk a bit about microshed testing. So microshed testing is testing for your microprofile projects. And this is great because it is a true to production test, meaning it will deploy it in a container for you, so you get as close to production as possible. And for today's demo, I've just pulled in a sample project already for the sake of time. But if we take a look, this is actually from our Open Liberty guides, which I can show you after this. This is a great resource if you're looking for walkthrough guides of how to get familiar with some of microprofile specs or microshed testing. So here, I've just pulled in our drink and menu service classes that you saw before. It's just the same, and we're going to write some microshed test classes for this. So if we look here, this person service, that's coming from the existing project I built on top of. But we'll start sort of from scratch here. Oh, and you can see here in Intellij, we have an Open Liberty Tools for Intellij extension as well. So the same with VS Code, we have now a Liberty Dev dashboard, and it will detect your Liberty projects for you and show them here in the dashboard. And if I expand this, you can see we have all of the same sort of functionalities here. So we can start, we can custom start, stop, run tests, view test reports from your dashboard. All right, so back to microshed tests. To work with microshed tests, you just have to add a few dependencies to your POM. So I have here the microshed testing Liberty dependency and the JUnit Jupyter dependency. So when we define a microshed integration test, we want to use our microshed test annotation. And this is coming from our microshed testing dependency. And then the next step is to define your container. So microshed testing is built on top of test containers. So we're using the container annotation from test containers. And what we're doing is specifying an application container, the context root, and then the readiness path. So this will tell it when the application is up and running. So in this case, it'll be health/ready, which is the default. And now we want to enter our REST client as well. So you have to be careful here to select the REST client annotation coming from microshed testing, not the one we previously used coming from Microprofile REST client. And we want to call our menu service here. Our menu service. All right, so now we're ready to write our first test. So I want to use our test annotation, and this can just be a simple test for whether our menu is available. Obviously, your tests can be a lot more complex as you want them to be. So I'm just going to check the number of items we have in our menu. So I'll call menu service, get menu size, and I'll just use equals. We should have 2. Remember correctly. And we're ready to run our test. So I'm going to run Nvm Verify in our terminal here. And so what this is doing is starting up a Docker container for just your tests, and it launches a Open Liberty server in that container. And that's what it means by true to production test. So your application is running here. So we just have to wait for it to start up, and we can see our tests run, and we had no failures. So the 2 tests run, that's the existing person service test, and then our new menu service test here. And you can see we got a response from the server. That's our menu, and we had it pass. If I changed it and ran, we would see it fail. All right, there you go. We got a failure because expected 3, but was 2. And that about brings us to the end of the demo. If you want to check out more about microshed or any of the guides I was talking about, you can go to openliberty.io/guides. And here's a bunch of guides you can filter. So the one I built off of, if I search microshed, there's a full guide here detailing how to use microshed, and you can walk through it. So I definitely suggest you check those out. And with that, I will pass it back to YK.
All right, thanks. Thanks, Catherine. Thanks a lot, Q, for showing us, taking us through what's available in terms of tools for building applications with Microprofile, from getting a starter application created to the coding assistance that we'll get, working with the different editors to testing. Thanks a lot, Catherine. So that brings us pretty much to the end of our stream here, or our session here. So let me just recap what we have done by looking at what we've talked about. So we started off today with obviously a look at Microprofile GraphQL with OpenLiberty, and he did that for us. And then Ron came in and showed us the new language server for Microprofile and what it is, where you can find out where you can get it downloaded, I guess, at least for VS Code, and how you can contribute. And also, lastly, Catherine came in and showed us the different tools that's available for Microprofile developer. All right, so yeah, that's pretty much what we want to cover today. We know in a few minutes the conference will be closing, so it's been great having to be able to be here and show you folks what we have done for Microprofile and what's there for Microprofile for developers, right? So yeah, as Catherine mentioned, as we indicated earlier, so we work on OpenLiberty ourselves. Feel free to check out the OpenLiberty project and let us know if you have any feedback. And also, Catherine touched on the guides that we have. We do have a set of guides on actually all the Microprofile APIs and different technologies around building applications with Microprofile. Feel free to check them out and try them out to have fun with Microprofile. All right, so that's pretty much it for us here today. Let me see if we have any other questions. If not, then yeah, feel free to reach out to us at any time, and I'll be ending the stream shortly.